You've clicked on this video because you want to finally understand Azure networking. Maybe you're a developer who's been told to deploy an application, or you're just starting your cloud journey. Either way, you're in the right place. This isn't just another boring theory video though, because we're going to build a real-world network setup from scratch using Terraform, and by the end you'll understand the core components that make up Azure networking. We're essentially building two landing zones and we're going to connect them together. And finally, we're also going to connect them to the internet in a secure way. So we're going to start with two empty Azure subscriptions, but if you only have one, that is fine. You can still follow along. But we're going to hit a critical point where our networks can't communicate with each other, and I'll show you how we can fix that. And stick around to the end because I'll show you the one service that can centralize all your network security and is what is used in all business and enterprise environments that you will be working within in the future. This is going to be a hands-on tutorial. I will be in VS Code writing Terraform. I'll also be in the Azure portal showing you exactly what we're building and why. I will move at a steady pace and I'll try to explain everything along the way. My name is Carl Lindberg. I'm a Microsoft Azure MVP. I've spent years designing and building Azure landing zones for major companies. I've seen where people get stuck and I've seen what works in production. I'm gonna try and distill all my experience down into this video. We're not just gonna learn what a virtual network or a VNET is, we're gonna learn how we can use it in the broader sense in a cloud environment. There are many ways to think about virtual networks in Azure. Something that like traditional network technicians may be a little bit confused about if they've never seen Azure networking is, what even is it? And an explanation I received once, which was very helpful for me, is you could think of virtual networks in Azure a little bit like switches or virtual switches, and the subnets within a virtual network you could think of as a VLAN, for example. If you're a network engineer and that resonates with you, that's great. If you're not, or if you don't understand what I just said, don't worry, we are gonna make everything clear in a little bit. But basically we have our virtual network, we're gonna create subnets to organize our resources. So we're gonna jump into VS Code and we're gonna define our first virtual network and a couple of subnets for our first landing zone using Terraform. Okay, so basically right now I have two Visual Studio Code windows open, Network A or Landing Zone A, and Network B or Landing Zone B. And what we want to do is we want to make sure that we're going to create all the piping for these so we can start writing our virtual network. Okay, I fast forwarded a little bit because I've done the bootstrapping, if you want to call it that, a lot of times before on camera, so I just thought I'd skip that. Just to recap that for each of these projects I've created the Terraform block, I've set the provider and added the provider block. I've added the variable Azure subscription ID. On the left, this will be like the production subscription in this case, where we have the Azure subscription ID for my production subscription and the environment is going to equal prod. And I've done the same on the left, but I have a dev.tf-vars where I'm going to say that the Azure subscription is different to the one in production. I'm lucky to have two, so I can show you that we can do this cross subscription. But again, if you don't have access to more than one, you can just differentiate on a resource group level. That's fine as well. Okay, but let's actually start doing some things. So we want to, first of all, we want to create a virtual network. Otherwise, this will not be much of a network tutorial. We can call it this because this will be the only virtual network in this project. We don't have to give it a more specific name than that. I want to set a name. I want to have a prefix of VNET and I want to set the environment. So when this gets deployed using this environment, it's going to be VNET-prod and we'll do -beginner networking. Then we have to say the resource group name, like you were probably already shouting at the screen. I don't have a resource group, so let's do that first. Resource group, we can call this as well. The name here could be rgvar.environment beginner networking. If we don't want to type this all the time, we could say that we will replace beginner networking with var common name, and we'll have a new common.tf-vars where we say that the common name equals beginner networking. And then we have to define that as well, so we'll say variable common name type string. While we are in here, we can say that we need a new variable as well called location. So we'll say string for that as well. And we could say in common, we'd say that location should be Sweden Central. So now that when we are back in our main.tf, we can say that the location should be var.location. Now we can reference this to be able to set the name as well as the location to set that from the resource group as well. We'll format this. So now we have the interesting part about the address space, right? So an address space, we have to give this a list of strings. It is very important in a cloud environment that you're actually planning your IP addressing. What I mean is have some sort of IPAM, like IP address management tool or something to track what workloads are using what virtual network address ranges, just so we don't have an overlap. Because for a future task, we're not going to be able to complete it if we have the same overlapping address space. But I actually want to make this a variable as well. So we're going to say VNET address space, and the type we can say is a list of strings because that is what it takes. And then we can say vnet address space inside prod.tf-vars. We'll say this is a list as well, and maybe we assign this 10/0/24. Not a super large virtual network address space. And then all we have to do is say var.vnet address space. Awesome. So now we want to create a subnet, so we can further divide or slice our virtual network into different subnets. This is important because we don't want everything into the same subnet necessarily. We want some way to group them logically, and we can then use network security group further and more granularly control access. If you don't understand what I'm talking about, don't worry, we're gonna touch on this technology in a little bit. So for subnets, I guess we say we could have one called application. For the name, I would just say application in this case, or application subnet, I guess is fine. Then we have to say what virtual network does this belong to, and we can dynamically reference this by looking at the object we already created. Should be set resource group name as well, just like we've done before. We can do it like that. And then address prefixes, and this is also a list of strings, so we can do the same thing here. Actually, I'm gonna say that application subnet is one list, and I'm gonna assign this 10/26/26. We are also gonna pretend to have a database subnet. This is not something like we're gonna do something super elaborate with for this guide. This is just to, if you've never seen subnetting within an Azure Virtual Network before, this can kind of give you an idea of, oh, I get it. You would have your application servers maybe in one subnet. You would have your database subnet, your database servers in one subnet. Subsequently, if you have like a web server, maybe that goes into a web subnet, and so on and so forth. I'm just gonna assume that the subnetting here is correct and that it's not gonna yell at me. So what we wanna do is we wanna make sure that we have variables for these. So I can copy application subnet from here, say variable application subnet, type list of strings, equally, I wanna have a database subnet. And in our main.tf, we can say var.application subnet for the address prefix. And I'm just gonna copy this. And yeah, like Copilot is alluding to, everything here should be the same except for the name. Obviously, the name should be database subnet, and the address prefix should point to the database subnet. All right, so I am authenticated to my production subscription, so I can run Terraform init from here. Once initialized, I want to run a Terraform plan. I have to say that I'm using a few different variable files. So we're using prod.tf-vars, and I'm also going to be using common.tf-vars, and let's see if it likes what I've done. It didn't like that, and that is because I didn't say that I'm using another var file. So I have to say var file twice here, basically. Okay, let's go again. Okay, so we have a successful plan. It wants to create a resource group. It's going to be called rgprod beginner networking. And remember, we are in one point of view of a landing zone right now, where we are saying that this is production. So when we deploy the same code, which I'm going to show in a little bit, everything should be somewhat similar, but it should be called dev, right? So we get our subnet, and the subnetting looks fine. One subnet for application, one for database, and we get our virtual network. So I like what I see. So I'm going to go ahead and say apply, and I'm going to say auto approve. While this is running, I should mention the point of view, or like why we're doing two different projects, is because I want you to assume, like, right now we are deploying Azure resources with Terraform, and we are assuming that we are the administrators of this landing zone. When we are going to deploy this from the other project, which I'm going to do in a little bit, just assume that we are some other administrators. We don't manage the same things. It's just to illustrate that you have two different parties that are deploying networks in Azure, and they may have the use case where they need to communicate with each other. And that is what we are trying to solve in this video. If you don't understand what I mean, I wouldn't worry too much about it. Just know that we're gonna set up a scenario where there's gonna be a requirement for us to connect networks together and make sure that they are communicating effectively and that they can reach the internet in a secure manner. Deployment was successful, so if I search for a beginner, I should see I have my resource group as well as I have my virtual network. If we click into this, I should be able to see that I have two subnets. Awesome stuff. Okay, so to save on a little bit of time for our other landing zone where we're deploying the separate network infrastructure, we have the same code basically for the main.tf. We want to deploy the same set of resources. The things that differ is obviously we have environment dev instead. Then we have a different Azure subscription compared to the one we just deployed. And I've also updated the ranges for the virtual network and the subnets so we don't overlap basically. So I'm gonna go ahead and deploy this, and I'm gonna cut to the next part. So my deployment into dev is successful. And if I go to my dev subscription, I see I have a RD dev beginner networking with a virtual network and the subnets. And they have a different range. And just like that, we have a home for our applications and our virtual machines, our private endpoints, like anything you could think of, you have somewhere to put them where they can live. Okay, so off camera, I've deployed two virtual machines, one called VM Dev Beginner VM and one called Prod, and they are placed in different subscriptions. Equally, they live within different virtual networks. The problem here now is that these virtual machines, they cannot communicate because they are in different networks. They, by default, can't reach each other. And then you may think, yeah, but you could have placed them in the same virtual network and then they could most likely talk to each other. And while yes, that is true, it is very much not recommended having all your compute power in your infrastructure in one huge virtual network. That is a surefire way to have a mess of an environment, have lots of security risks, and have a hard time administrating your machine fleet, basically. But I think you knew that already. But how do we make sure that they can communicate? Well, the solution is virtual network peering. Virtual network peering is basically a link between two virtual networks that allow them to talk to each other, and it lets traffic use the Microsoft private backbone network to go from source to destination. So here I've switched back to project A, or landing zone A if you will, and let's define a peering resource. We can do this by saying resource Azure RM virtual network peering, and it can be called this for now. So there's a bunch of different things we have to give this. First we have to set a name, and I'm just gonna say VNET link A to B. Naming is hard, especially when you're just doing a demo. We have to set a resource group name, so I'm just gonna use the resource group you already have, say the name for that. We have to say what virtual network do I want to peer, and in this case I'm saying I want you to peer my virtual network, the one I'm telling you here that has this, not ID, that has this name. But the second part of this information is, okay, you want to peer your network, but what other network do you want to pair it with? And that's where we have something called remote virtual network ID. So here I'm cheating a little bit, but I'm just going to go ahead and copy in the resource ID of the other virtual network that we had created. I'm going to set myself back to my production, and then I'm going to run the plan again. I also forgot, I think we have to say that we want to allow forwarded traffic. I'm going to set that to true. So after updating that, I'm just going to run a plan again to make sure that it gets reflected into the plan. So it wants to create one virtual network peering, VNET link A to B. I think this looks okay. So I'm going to run an apply for this. So the apply was completed successfully. So let's have a look at it in the portal. So if I open my virtual network, I have in the left pane something called peerings. I do have my peering, VNET link A to B. It says remote sync required and that the peering state is initiated. What does this mean? This means that from my point of view, I have requested or asked or initiated for peering, but the other virtual network, my target network, has to complete the handshake, say, yeah, it's fine, we can peer. So if I go into my remote virtual network, the one in dev, I go to peerings, I don't have anything here. To resolve this, we can simply copy this, go into my dev project or the other landing zone, if you will, add this to here. Let's call this VNet link B to A in this case, because it's the other way. Update the resource ID here to make sure that we are pointing to the production. Here you can see the production virtual network. And let's run an apply from this side as well. So I ran the plan, it looks good. It wants to add the virtual network peering, link B to A. Let's run an apply for this. The apply was completed successfully. Now if I go back to peerings, we should see, yep, it is fully synchronized and connected. So now we have two virtual networks that are peered and are able to talk to each other. So what I can do is from my production machine, I can go to run command, I can run a shell script, and I can check to see if a remote port is open. So this is the IP address of the dev machine. And let's say I want to check if port 22 is open. And just like that, I was able to establish connection. All right, that is actually a pretty huge step. Our two virtual networks are now connected, and our workloads in the one network can reach and talk to workloads in another network. And that's great, right? Well, we do have an issue with this actually, because our networks are peered, but right now, any resource in the virtual network can talk to any other resource in the other virtual network. There is no segmentation and there's no denying of any traffic. It's like a free-for-all for everything. This means that, yeah, I could have a web application that can talk to a database server, both within my own virtual network, but also in the peered virtual network, but they may be not even related. They're perhaps two different applications and belong to two different entities altogether. And that is not what we want. We want more control than this, and we want more segmentation than that. This is a major security risk because if one machine is compromised, we enable a lot of lateral movement within our network. So we need rules. And one way we can fix this is by using something called a network security group, or NSG. Think of NSG as a lightweight firewall, if you will. It's definitely not a firewall. Basically deny or allow traffic without any advanced cool features of a firewall. I was able to connect on port 22 to another machine. Let's say we wanted to make sure that that is not possible. So now I'm the point of view of the dev landing zone or project B. I keep calling it different things. I hope you can follow. But this is the subscription where we have the machine where I checked if the port was open. So we'll create a new resource. We're going to say we want to have a network security group, can call it this, and we're going to give it a name. I'm going to actually copy the name resource and just say NSG instead. The resource group name, yeah, we did this before, or we've done this a few times. Location, yeah. And this is pretty much all I need actually to be able to create a security group. So let's run a plan. The plan looked good, so let's run the apply. The apply was successful. So now we want to create yet another resource. We're going to say subnet network security group association, because this NSG, it's just a resource in Azure. It's not tied to anything right now. And we have to tell it what we have to tell it what subnet do you go to. And it's pretty easy. We say the subnet ID. In this case, we want to put it at the application subnet because that's where I deployed my machine. And the network security group we can reference as well by the one we already created. Awesome. I'm just gonna assume that this works and run apply. Definitely not best practice, but we need to save on a little bit of time. Deployment is successful, awesome stuff. Okay, before we test, you may see I have a new shirt. That is because this is a new day. So I was recording for about over 2 hours yesterday, and everything after minute 55 of this tutorial was not captured on the screen. So one mental breakdown and a good night's rest later, I am back, and hopefully we can have less mishaps today. But I do know that I just appended the network security group and associated to the subnet. So let's try again to run a command from the source machine like we did earlier to the destination machine in the dev environment and see if we can still connect or if we are being timed out. So again, I'm just gonna run the same command, same port, and just see if it's gonna allow me to go through. And the connection timed out. You can almost tell because it took a long time, then it's usually something that's wrong. And this is because at the network security group that we assigned at the destination machine or at the subnet where the destination machine lives, we are denying port 22 basically source anywhere. So we're not allowing anything. This is a very broad deny, but we could be even more granular now and say, yes, we don't want to allow SSH from anywhere, except for this one machine that we know needs to talk to this machine. So we could say that the source could be an IP address, and then we want to set the IP address of the machine I'm trying to reach from, which is this one without the one, so it's in another virtual network. Source port could be any. The destination, I only want to allow it into this machine that I have here in dev. So I'm going to set that. I can set the service to SSH, so it's going to hard code port 22 for me. TCP, it is important that I set this as a higher priority now. Otherwise, this is not going to work. So I could set this as priority 90. Oh, the priority must be between 100 and 4096. Let me fix that. Okay, I just bumped the priority to 110. We're gonna say destination. Those of you who knew that that wasn't gonna work and were laughing at me, screw you. Just kidding. So then SSH, destination port 22 still. We wanna set this as a higher priority and say allow prod VM. And we can go ahead and add this rule. So now if I come back here, you can see we still have the connection timeout from before, but let's run this again. And now the connection is successful again. Pretty awesome stuff. So NSGs, as you can see, they are pretty powerful, but they do lack certain things that we need in an enterprise or a business setting. They are simple, like deny and allow rules, and that is great for that purpose, but we usually use them for protecting intra-virtual network traffic. What I mean is you usually use them to divide traffic between, if you have several subnets within your virtual network, you could have a network security group on each subnet, saying that for your web subnet, you only allow a few certain machines to talk to the web servers over a specific port, for example, instead of just default allowing everything. But when we need to control traffic out on the internet, or when we need to control traffic between two different landing zones or two different virtual networks, they are not really good enough. And why they're not good enough is because we don't get any advanced security features. We don't get much in terms of logging. There's some logging, but not at the level that we need it to be. And this is very important for traceability and making sure that we can be much more granular about control to any network in our environment. So how do we solve this? Well, we can deploy a firewall in our environment. You will always see a firewall in any serious cloud environment or on-prem environment for that matter. It's the firewall or an NVA, network virtual appliance, that we can use in order to control traffic between our virtual networks and also traffic out onto the internet. An Azure Firewall is basically a firewall as a service, and it gives us a lot of abstraction. We don't have to think about a lot of things. We get some stuff for free, which can be very good for us at the expense of maybe not being able to be too granular about our configuration of the firewall. But in most cases, we don't need it. In most cases, I think it is good enough. This is gonna finalize our diagram that we looked in the beginning, where we're gonna turn our landing zone A or subscription A into a proper hub, where we're gonna install an Azure Firewall. And then we are gonna make sure that from our landing zone B, where we have our dev machine, we're going to ensure that we can control traffic out onto the internet in a secure manner. So in order to be able to do this, we need to go back to our project A, landing zone A, environment prod, or whatever it is nowadays. And I'm actually gonna grab my one subnet. I'm gonna say that this one is gonna be called firewall. So we need a subnet for the firewall. And for Azure Firewall, the name of the subnet, it is very important that it is written exactly as I will write it now. Azure Firewall subnet, but otherwise we're not going to be able to put the firewall into this subnet, and it's going to use this entire subnet, making sure we can't do anything else with it. I think we do need a minimum of a /24 in this case, and I'm actually just going to use the entire virtual network range that I had. It's going to be one subnet, and it's going to be the Azure Firewall subnet. I don't need the database subnet any longer. What I do need is I need to say that I want to create a public IP addresses, which for my machine, when it's going to talk out on the internet via the Azure Firewall, it needs to use this public IP address. So I'm going to say Azure RM public IP, and I'm just going to call it this for now. The name we can borrow from our VNET, just replace the prefix with pip for public IP address. For sake of time, I'm also going to just copy paste the resource group name and the location. Then it tells us we need to set an allocation method. This one should always be set to static, because you don't want this changing. And the SKU, I'm gonna set this to standard. To make it easy on myself, I'm gonna use a standard SKU Azure Firewall, and I think I do need a standard SKU public IP address in that case. Also, a word of warning if you are following along, an Azure Firewall, especially from the standard SKU and the premium SKU, are very expensive. I'm deploying this into an environment where I have credits that can expire and then they get refilled. But if you have a Azure subscription on a pay-as-you-go link to a credit card, perhaps just watch this or deploy it, but make sure that you remove it immediately. There used to be, I don't know if it is like this any longer, but there would be like an upfront cost immediately when you deploy the firewall, which can be very expensive. So if I were running this on a credit card, I wouldn't bother. I would just watch this demo part instead. And I have to say this because I don't want anyone going bankrupt because of me. So I'm gonna say that I want to create an Azure Firewall now. Again, I'm gonna copy a little bit from a previous resource, but now we want to call this FW for firewall. We have to set an IP configuration, and I'm gonna accept what Copilot is suggesting, so we can set the name can just be configuration. The subnet, I want to place it in the Azure Firewall subnet, so it's going to get an internal IP address that I need later. And I'm also going to get the public IP address, or I'm going to set the public IP address. It wants us to set the SKU name, which we could set just to ACFW VNet for now, and the SKU tier to standard. Now, this on its own is just going to deploy the compute unit of the firewall. This will not, however, let us control any network rules or application rules. In order to be able to do that, we also need to create what's called a firewall policy. Shamelessly steal here again. Copy pasting is not always bad. We changed the prefix to FWP for firewall policy. Now we can say the SKU should be standard, so we are matching. I don't know if there's much else I need to set right now, so let's run a deployment for this. I'm gonna set myself to my production subscription again. This is not medicine, this is Azure. I'm gonna run a plan. Okay, so it wants to create a new subnet for the firewall. It wants to create the old subnets, which we're not going to use anymore. And it's going to create the public IP addresses that it's going to attach, the public IP address that it's going to attach to the firewall, as well as the policy and the firewall itself. Oh, and also before I deploy this, I remember I do have a virtual machine in one of the subnets I'm destroying. And it's not going to let me destroy this unless I remove the machine. So I just need to be right back and delete that machine quickly. While that is happening, before we deploy the firewall, I just want to show you that this is the virtual machine that we're keeping, that we're gonna make sure that we use the firewall for outbound access. Right now, we're not using the firewall because it doesn't exist. I just want to illustrate to you that if we come down to run command here, let's run a new command and say I just want to send a web request to ipinfo.io. I'm gonna use something called implicit access, so I'm just gonna get assigned a public IP address sort of in the background. It's a little bit of magic. I don't have a public IP address specified for this, but I'm just going to get one. And you can see here that I was successful in my web call, and I received that I have this public IP address and it belongs to the Microsoft Corporation. But the point I'm making is I'm able to reach the internet basically. And remember this IP, or have a look at this IP, because we're gonna show you how this changes as well. And the VM is gone, so I'm gonna run apply to make sure that we deploy everything that's gonna be related to the firewall, and I will get back to you once this deployment is complete. We actually forgot to do something as well. We have to say on our firewall, we have to tell it which policy ID should you use. So we add this on here. I'm gonna update the firewall and be right back. Okay, so my firewall is deployed and you can see it has a private IP address of 10.0.0.0.4. This means it is a part of one of the virtual networks that we created, the one we have turned into a hub. Problem now is, if I just come to my machine and I just run curl again, it still works and I have a new IP address, but it's not the IP address that we used to deploy the firewall. So this one is not really using the firewall at all right now. How do we solve this? We solve this by creating what's called a route table. So a route table is a resource that we assign to a subnet, and it's going to basically say that any client within this subnet, when you are trying to make outbound calls, if you hit any of the routes that I specify, go there via the way I tell you to. So what we need to do, we need to make sure that our dev machine, whenever it is trying to reach the internet, it needs to use the Azure Firewall. We can accomplish this by creating, first of all, a route table. So we have a resource called route table, can name it this. I'm gonna borrow from the network security group and just gonna replace this with RT. Then we need to create what's called a route. So a route is a child resource in this case of a route table. So when we say that we want to create a route, we can call this route, because in an environment you would usually have a lot of these, so we could be a little more verbose here and say route to internet via Azure Firewall. We say that the route table name that we want to assign this route to is from the route table that we created earlier. So we want to say name. We need to give it a name, so we can say route to internet via firewall, I don't know. Address prefix. So like I mentioned, this is going to be assigned to a subnet, and what address prefixes do we need to enter in able to make sure we do the right things when we try and reach the internet? Well, in Azure, it's basically this. The way routes and route tables work is that the most specific route wins. So this is a very unspecific. So it'll be like a catch-all for anything. So when I am trying to reach ipinfo.io, for example, if I'm trying to reach portal.azure.com, I'm going to receive like a range of different IP addresses. It's not going to be very specific. So if I don't have a specific one, this one is going to get applied. And then I can say that the next hop type should go via a virtual appliance. So Azure Firewall in this case qualifies as a virtual appliance. We could say that you could just use your VNET local like you do now. A gateway perhaps, if we were doing this, we need to route something through a VPN, but we just need a virtual appliance. And the next hop in IP address, we just enter the IP address of the Azure Firewall. And we have to say resource group name, just to build the resource ID, I would guess. So we just say this name. And this is basically saying that if you're trying to reach the internet, I want you to go via a virtual appliance, and it's this virtual appliance. And I got the IP addresses from the firewall being deployed earlier. Finally, these resources are now good on their own. We need to make sure that they are associated to something. So we have a resource called Azure RM Subnet Route Table Association. Call it this. We can say that the route table I want you to use is the one I just created, ID, and it's going to use every route within that route table. And the subnet, right now my machine is in the application subnet, so I'm just going to make sure we use that one. I'm going to go ahead and deploy this and we'll see what it looks like. So that was deployed successfully. If I do a refresh here, I can see on my application subnet I now have a route table, and it has one route saying route internet via firewall. This is the prefix we set, virtual appliance, and next hop is firewall. And this machine that is in the virtual network of the range 10.0.1.0/24, it can reach the appliance that lives in 10.0.0.0/24 because we still have the virtual network peering between these two virtual networks. So if we come back here and say, I want to run my curl command again, I'm going to make another web request. This time I should go through the Azure Firewall. And something else happened, right? Now I wasn't able to connect. And that reason is because the Azure Firewall, if there is not a specific rule that allows or denies something, it's the default action to deny it. And we've only created the firewall, but we've not configured any rules for it. So we can take a look at that right now. So if I come to my firewall, I can click on my policy because this is where I control this. I have here at the left network rules and application rules. When we're talking about network rules, think layer 3, layer 4. We're talking TCP, UDP, those sorts of protocols. When we're talking application rules, we're thinking more layer 7, HTTP, HTTPS, URLs, that kind of thing. So I can say I can add a rule collection. I can call this allow IP info IO, for example. I have to give it a priority value. I can just give it 100. The action is going to be allow. I can place this in the rule collection group that is already there. And then I'm going to specify the rule. And the source type, I want to set the IP address of my machine that I'm trying to call from. I can say I'm using HTTPS 443. And the FQDN, say I want to reach ipinfo.io. And I can add this and it's going to create the rule for me. So now if I'm back at the point of view of the virtual machine and we try and run this curl again now that I've added the firewall rule to allow this, hopefully it should let me through, so let's see. And there you go. You can see I now get my response. And also we have another IP address. I'm using a different public IP for connecting to things on the internet. And what IP is this? Well, if I go to my firewall, I go to my public IP resource and I search for it, you can see it's the one attached to my firewall. This is very great because now I can say that any virtual network, any client, any resource that I force through this firewall, I can say that if you have a service, for example, and you need to allow me through, you could potentially whitelist my IP address, that is this IP address, and it's going to be the same for all of my clients. So we've covered a lot. Like I mentioned before, I've done this tutorial over 2 days, so I don't even know half the stuff we've covered, or I can't remember, honestly. But there are things we haven't touched. We haven't touched things like private endpoints. We haven't touched DNS. But I felt like for a beginner video, I want to leave them for another time. I also haven't shown you how we could do the NSG rules and the firewall rules in Terraform, which if you want to, that can also be another video. But I hope you've enjoyed the contents of today. We have gone through how to think about virtual networks, how to think about connecting virtual networks, how to reach the internet, what to think about when designing your strategy for your networks in the cloud. If you found any of this valuable, please leave a like on the video, subscribe to the channel. If you want more things like this, I have a bunch of other things on my channel already, but I'm also creating more guides and more videos all the time. So that's gonna be it for me today. I appreciate you watching a lot. Thank you very much. I will see you in the next one. Bye bye.